Hey grade 12s and welcome to this video. So we're on question 8 and 8.1 says determine f prime of x from first principles if f of x is equal to 3x squared minus 6. Okay guys, this is 4 marks, so this is really a place that you can score marks. So we're going to go ahead and find the derivative of this function, or the gradient really. Okay, so what we can go ahead and do first is, because we know that the formula we're going to use is f prime of x is equal to the limit as h approaches 0, and then our formula is f of x plus h minus f of x all over h. Remember that this is in your formula sheet. So because we're using this formula and we already have f of x, okay, we need to find the f of x plus h. So that's what we're going to go ahead and do first. So we're going to keep this aside and go ahead and find the f of x plus h. So when you look at that formula, that f of x plus h, you see that all they did was add an h to wherever they see x. And that's what we're going to do here. So f of x plus h is actually equal to, and we have 3, see x squared over there. We're going to add an h to it. So it now becomes x plus h all squared, and then minus 6. So we just have to simplify this equation or expression really. So this is equal to, we still have our 3, and let's distribute. So you can do the whole thing with 2 brackets, but that takes quite long. So what you can instead do is just square the first term, which gives you x squared, square the last term, which gives you positive h squared, then multiply the first and second term, which will give you xh, and then multiply them by 2. So that gives you positive 2xh. So I need some space here. Okay, and then we still have our h squared. Then minus 6, and now we can go ahead and distribute the 3 into the bracket. So we're going to have 3x squared plus 6xh plus 3h squared, and then minus 6. Okay, so now that we have our f of x plus h, we can go ahead and substitute it into our formula. So this is our formula, and we're going to go ahead and say this is equal to the limit as h approaches 0, and substitute our value. Okay, so we're just taking this whole thing that we have here and substituting it in place here. So just be careful with this part because you can make little mistakes. And now we are subtracting it by f of x. Now f of x, as you can see, has 2 terms. Because you have 2 terms, you need to protect this with brackets. So it's going to distribute in. So we're subtracting by 3x squared minus 6. Okay, and all of this goes over h. Then we're going to go ahead and distribute. So you can distribute from here. You can also distribute from here. It's still fine. So this is equal to the limit as h approaches 0 of the same function that we have. Then we're going to distribute. So that becomes a negative 3x squared, and that would become a positive 6. And then it goes all over h. Now, the thing about this part is, you know that whatever you were subtracting by, that is the only thing that's going to cancel throughout here. So I'm looking for something that has a 3x squared. There we go. We have a 3x squared. That cancels with that. And then with 6. So the negative 6 will cancel with the positive 6. Okay, so all we're left with right now is we still have the limit as h approaches 0. We have 6x h and then plus 3h squared, and then nothing else all over h. Okay, so now we are getting to the final point, and the whole point of us doing all of this is really so that we can get this function or this expression to a point where h is not the denominator, because you see that we are approaching 0. So we need to substitute in place of h, 0. We don't want that to become undefined. So what we can do there is take out a common factor of h. So take h out as a common factor, and we're left with 6x, and then what are we left with here? So you just say that divided by that, and you get positive 3h all over h. And so your h's cancel. Now, even if you didn't add this step and you just went ahead and divided, it's still fine because there is some sort of factorization that we can see that was implied. Okay, there was some sort of implied factorization. So we have that is equal to, so at this point, you can rewrite this again, but then you have to rewrite that lim of h approaching 0. I'm just going to go ahead and substitute. So now I don't need to actually write that it's approaching 0 because I'm substituting 0. So that is 6x plus 3, and then in place of h we put 0. And so you know that 3 times 0 is 0, so our answer is really just 6x. So when we derive that, f prime of x gives us 6x. And just to check and make sure that you are actually correct, what you can do is go to your original function, and using the rules of derivative, you can derive that. You see, if you said the coefficient times the exponent, you get 6, and then you have x, and then you take the exponent minus 1, which is 1, and you don't have to rewrite that. And then you have negative 6, which is a constant. If you derive a constant, it becomes 0. So we know that that really is our answer. So you can do that, grade 12s, just to make sure that it is correct. Okay, I also wanted to add, if you guys are enjoying these videos, please make sure to give it a like and share. And you can also subscribe to see more content like this. It really helps with the growth of the channel. Okay, so that is the first question in question 8, and we move on to the next question. We are on 8.2, and 8.2 says, determine the derivative of f of x is equal to this. And this is for 5 marks. It is not using first principles, okay? They just want you to determine the derivative. They never mention first principles. So our function looks really weird, but there is a squared, and we have to actually simplify that. So you have to get your function to a point where it is simplified before you can actually derive it. It's kind of like preparing it to be derived. So we're going to go ahead and apply that squared. When something is squared, it really just means the same thing is being multiplied by itself twice, like that. Okay, so we can go ahead and just use that short method of distributing a binomial, or rather a squared binomial. So we have this, and what we can do is we take the first term and we're going to square the first term. So if you square this, the 2 squared becomes 4, and the root x squared, you see, that's going to cancel out your root there. So you're just left with an x. So that part is done. And then we're going to square the second term, which is the negative 1 over x. When something that is negative gets squared, it becomes positive. And then 1 squared is 1, and x squared is x squared. And then you're going to multiply the first term and the second term by each other. So here's what happens. We have 2 root x being multiplied by negative 1 over x. So they become negative. And then you see that diagonally nothing really cancels, because this is a root x and that is an x. It's not really the same thing. So what we can do is just multiply numerator with numerator. So 2 root x times negative 1 is just negative 2 root x. And then this has a denominator of 1 that we cannot see. So 1 times that just stays x. Okay, now we can actually simplify it further. So what we can do, well, just to show them that we did squared, we can just rewrite it here first. So we just have there, we have a minus 2 root x over x. And let me also just write this like that, 1 over x squared. Okay, so at this point, are we ready to actually derive this expression? No, okay, we're not ready to derive it. And the reason why is because you see that you still have x's on your denominator. They shouldn't be there. They should be on the numerator. So what we're going to do is go ahead and simplify these. So for this one, what we can do here is we're going to say f of x is equal to, and we have 4x. And instead of like just putting it to the top, what you can do is divide. This is still an x. We can just rationalize the exponent by rewriting that square root of x like this. So we have minus 2, and we're going to leave the base. Now, you see this minus and then this square root of x specifically, right? It has an inside exponent and an outside exponent. The exponent on x is 1, and the exponent on the outside that we cannot see is actually an invisible 2, because this is the square root, like you have a cube root as well. There's a 3 here. Okay, so we can just go ahead and say inside exponent over outside exponent, and that's how to actually simplify a surd so that its exponent is a rational number. Okay, so at this point we still have that, and we have over x. And what I'm really doing here now is I'm going to divide. Because I have an x on the numerator and an x on the denominator, I'm dividing. But when you're dividing things with the same basis, you're going to subtract the exponents. So the exponent here is an invisible 1. So we're really just saying a half minus 1, which gives you negative a half. So all of that really just becomes x to the power of negative a half. Okay, so that's what we have. And that's what happens when we simplify that. And then over here, we just have a plus, and that should not be on the denominator. What we can do here, because we don't have an x on top, we can actually move the x squared to the numerator. And when you do that, what happens is that the exponent becomes negative. Okay, so that is what our expression ends up looking like. And now we're ready to derive. So we can go f prime of x is equal to, and we're saying the coefficient times exponent, which is 4, and you have x, and you take the exponent, which is a 1, minus 1, which becomes a 0, but x to the power of 0 would be 1, and 4 times 1 stays 4. Then here, coefficient times exponent, you have a negative 2 times negative a half. Okay, so the negative and negative will cancel. But you see diagonally, the 2 and the 2 would also cancel. So there you're left with a positive x. And then in the exponent, you have 1 over 2. And you have to subtract by 1. So exponent minus 1. Which is going to give you, you can use your calculator, negative 3 over 2. And then here we have, okay, we're going to take the coefficient, which is an invisible 1, times negative 2, which gives you negative 2. Then you have x to the power of negative 2 minus 1, which gives you negative 3. And there we go. So there it is finally derived. If you like, you can rewrite the exponents being positive, or you can leave it like that. So if you wanted to rewrite the exponents being positive, you could rewrite it like this. F of x is equal to, and you have 4 plus. Now, you see the thing about this is your base is x. That's the thing with the negative exponent. To make sure the exponent is positive, you're going to have to take this base and move it. Currently, it's on the numerator because it's normal, its denominator is 1, the natural denominator of 1. So you're going to have to move it to the denominator so that the exponent can become positive. So that's going to be, you see, now the one that is here is not this one. It's just a placeholder of 1, the one that was actually in front of the x. So you have x to the power of positive 3 over 2. That can still go further. And then we have here, what is carrying the negative exponent? It's the x, not the negative 2. So nothing's wrong with the negative 2. Leave it there in the numerator and bring that to the denominator. Okay, now if you want to finally write it in surd form, this can go back into surd form like this. So f of x, f prime of x is equal to 4 plus, and you have 1 over. Now you see this, remember how I said inside exponent over outside exponent? Well, that's how you can actually rewrite that. So we're going to put it as a surd. We're going to put the x and put our surd. And the inside exponent is a 3. And the outside exponent is a 2, which we don't have to write because it's a square root. And then you have the minus 2 over x to the power of 3. So there we go. And that would be written in surd form with positive exponents. But you can also leave it like that. You will not get penalized for this. Okay, finally moving on to the next question. 8.3 says, given f of x is equal to 3x cubed minus, and we have all of that. The question is, determine the interval for which f is concave up. Okay, so I'm going to quickly speak about concavity and how that really looks. Remember, I just really try my best to put a little bit of some learning in the past exam papers. Okay. So with concavity, what we can actually first of all think about is the way this function looks. So it is a cubic function, first of all. And do you notice that the value of a, because you know that the cubic function is ax cubed plus bx squared plus cx and then plus d, which is your y-intercept. So if a is positive, right, you have a cubic function that looks like an n. I have explained this before in my past exam paper videos. So that is a if a is greater than 0. And if a is less than 0, you have a cubic function that looks like that. So it looks like a backwards n, really. Okay, so it looks like a capital letter N. And then this one looks like a backwards capital letter N. Now, the thing about concavity, I know that we don't need a graph to solve this, but I just want you to understand what it means. When something is concave up, the same way we think about a smiley face parabola, this is a concave up parabola, okay? because it is curved upwards. So when you are looking for the part of your cubic function that is curved upwards, where you're going to find this, as you can see, we can clearly see it here. It's over here. This is the part that is curved upwards. This is the part that looks like a smiley face parabola. But how you find out where exactly it is, you're going to have to find out where it starts. Okay, where does the concavity change? That is where the point of inflection is. Okay, so you're going to have to find the x value of the point of inflection. And if you find that point, you know that your graph will be concave up for every other x value that is greater than this point. That is, of course, for a graph that has an a value greater than 0. And then if your graph has an a value less than 0, is the other way around. You see that way it's curved upwards, it's here. Okay, so I'm only doing that just so that if they give you a physical graph, you'll be able to actually find that. But with this, we don't actually need all of this. We don't need the graph at all. What we can actually do here is this. If they ask you for which values of x is your graph concave up, all you need to do is find the second derivative of your function and find out where it is greater than 0. So just solve for this inequality, really. That's all we have to do here. And then when it's concave down, it's the other way around. It's when it's less than 0. Okay, so we're solving for this. So let's go ahead and find the second derivative as that. Well, we're going to go ahead and find the first derivative, which we already had. No, we didn't. Okay, we didn't have that of this graph. So it's equal to, you're going to say coefficient times exponent, which gives you 9, and you have x minus 1, which is 2. Coefficient times exponent, negative 6x minus 1. You don't have to write that one. And then plus 6, and you know the x falls away because of the exponent of 0. A constant, if you derive, always becomes 0. So this is our first derivative. Then find the second derivative. So f double prime of x, and I guess we can already just tell them is greater than 0, and then just derive that. So that's 9 times 2, which is 18, and you have x. 2 minus 1 is 1. You don't have to write that. And then minus 6, and the x falls away. So this is greater than 0. Okay, so now that we have this, we can go ahead and solve for this inequality. Please note, this is a linear inequality. It's not a quadratic inequality. So there is no confusion with this. You solve for this just like you would with an equation. So we're going to take our negative 6 over, and we have 18x is greater than positive 6. And then to solve for x, we divide both sides by 18. And that therefore means that x is greater than, what is 6 over 18? Okay, they both have a common factor of 6. 6 divided by 6 is 1. 18 divided by 6 is 3. And that is our answer, okay? X is just greater than 3. So that is, I think this is set builder notation. The other notation, no, this is actually interval notation. So if you wanted to write it in set builder notation, the one with like brackets and stuff like that, that one looks like this. So you could have written it like this. You see, you're really just saying that x is going to be greater, right, than 1 over 3. So if you have 1 over 3 here, you're saying that all my x values lie here, values that are greater than 1 over 3. So you could have written that like this. X is an element of. Now with set builder notation, you're always thinking about what is the smaller number and what is the bigger number. See, the answers are here. It's numbers that are bigger than 1 over 3. So the smallest number we're comparing it to would be the 1 over 3, and the biggest number would be positive infinity because it's heading towards positive infinity. So you're going to say that x is an element of 1 over 3, right, all the way to positive infinity. And then with the brackets, you see, if they didn't say x is greater than or equal to, you're going to put a round bracket because the actual number of 1 over 3 is not included in this answer. But if it was, you would put a square bracket, okay? Now for infinity, infinity always has a round bracket because infinity is not an actual specific number. It's more of a concept, okay? So this is what we have. That's how you could have written it as well. Okay, moving on to question 9. Okay, so question 9 says, 9.1, sketch below is the graph of f prime. Okay, so this has already been derived. And so it's the derivative of, and they give you the full equation of the original function. And tell her that points A, B, and C are the intercepts of f prime. Okay, so A, B, and C are intercepts, x-intercepts, and the y-intercept, okay, with the axes. The first question is to write down the coordinates of A, which I feel like we can fill in here, but it's fine. Okay, the coordinates of A, we're going to go ahead and find that. Remember that A is a point on the derivative of this graph. So if they gave you the original function, all you have to do is derive this function and you'd find out exactly what A is. A is intersecting the y-axis, so it is your y-intercept. Okay, so we're going to derive that function, see exactly what it gives us, and then find the y-intercept from that. So this is our function. Let's go ahead and derive. So f prime of x is equal to, that's going to give us negative 6x squared, and again, negative 6x, and then positive 12. So if this is our function, if this is our parabola, this parabola, what exactly is the y-intercept? The y-intercept is this number over here, because that's your c value. Okay, ax squared plus bx plus c. C is your y-intercept. So if that is our y-intercept, the coordinates of A would be the x value, okay, of the y-intercept is always 0, and then the y value is 12. So that is A. Okay, moving on to the next question. So the next question says, determine the coordinates of B and C. As you can see, B and C, I need to write that down. That is 12, just in case we need it. So 12. B and C, as you can see, are your x-intercepts. So we have to find the x-intercepts. Well, we can go ahead and find them by taking, you can't take the original because the original is the cubic function. The parabola is the derived. So we can take this formula, okay, our parabola, and go ahead and find the x-intercepts. So to find the x-intercepts, you have to make y equal to 0. So since this is our parabola, this is our y value, f prime of x there. So we're going to go ahead and say f prime of x is equal to 0. And we can substitute there. So we're saying negative 6x squared, and then we still have the minus 6 plus 12 minus 6x plus 12 is equal to 0. And we just have to solve for this. So do you see that they all have a common factor of negative 6? So you can divide both hand sides by negative 6, and then you're going to get, so that is going to give you x squared, and then this will give you positive x, and that's going to give you a negative 2 is equal to 0. And now we have to factorize. So x times x gives us x squared. Now we need factors of negative 2 that can give us positive 1. So factors of 2 really just 2 and 1. Because that is negative, 1 has to be negative, and they need to, when added, give us positive 1. So you can make the 2 positive and the 1 negative, because 2 minus 1 is positive 1. That's what gives us the positive coefficient of 1. So that's positive 2 and negative 1. And then solve for x. X is either equal to negative 2 or x is equal to positive 1. And now we can just decide which one is B and which one is C. So negative 2 and positive 1. As you can see, B is more on the left. Again, it's the negative value. So negative 2, and then C is positive 1. So as coordinates, you can go ahead and write it like this. B is negative 2 and 0 because it's a x-intercept, and C is 1 and 0. And there we go. Okay, moving on to the next question. The next question is just a question, really. They say, which point on the graph of f will have exactly the same x values as B and C? So which points on the original function is going to have the exact same x values as B and C? So you see, with a cubic function, this is the derivative of that cubic function. The points that would have this exact same values, because this is concave down, it means your cubic function's a value was negative already from the beginning. That's why, as you can see, it is negative. So it's going to form an upside down n, or backwards n, really. Okay, so it forms a backwards n like that. And so the points that would have the exact same x values as B and C, okay, as your x-intercepts of the parabola, okay, the derivative of your cubic function, that would be your turning points or your stationary points. That's what that is, okay? So it's going to be your turning points. I'm sure if you say stationary points, it'll still be fine. Okay, so we can just go ahead and tell them these are the turning points. Okay, and that's for 1 mark. Moving on to the next question. Then the next question, 9.1.4 says, for which values of x will f be increasing? So not concave up or anything like that, but increasing, okay? So this actually has to do with the gradient and really what the function is doing. So if you have a line that's doing this, you read graphs from the left-hand side to the right-hand side. Would you say this line is moving up or down? It's moving down. If you read it from the left to right, you see it's moving down. And so this would be decreasing, okay? So if you want to see a function that's increasing, it needs to be moving up. So that's what we're really going to be looking for in our original function. So we kind of have a rough sketch of what it looks like, something like that. It could look a little different. So we have this, and let's look for the places that this graph is increasing. If we start over here, look at what the graph is doing. Remember, you move from left to right. So if we're moving like this, you see that we're moving down. Okay, so it's decreasing there. And then over here, what is it doing? It is increasing. And it stops increasing there. Okay, at the stationary point, it actually stands still. It's stationary. It stays still here. Then it starts to decrease again. So we can see it's all of this part of the graph here. And how we can actually answer them is using the stationary points, because at the stationary points, the graph is neither increasing nor decreasing. So at this point, we can say that this is where x is greater than -2, but less than 1, because you see it's increasing from -2 all the way to 1 as x values, of course. Okay, so that is our answer there. We'll tell them that it's increasing for x values that are greater than -2, but less than 1. Okay, moving on to the next question. 9.1.5 says, determine the y-coordinate of the point of inflection of f. So the point of inflection, you simply find that by making the second derivative of your function equal to 0, because the point of inflection is just that point that the graph changes concavity. So it's concave up here, then you reach the point of inflection and the concavity changes to concave down. Okay, so that is what they want us to find. They want us to find the y value. So to find the y value, you first have to find the x value. Then when you find the x value, you take that x value and substitute it into the original function. And that will help you to find the y coordinate belonging to that x value. Okay, so let's go ahead and do that. So we have already derived this function. I might as well just say f double prime of x is equal to 0, because I already have the derivative of this. The derivative of this is this function. Okay, let me just start by saying f prime of x, first of all, is equal to, and we have this. So that is -6x squared minus 6x plus 12, right? That's what we have there. Okay, so now that we have this, we can go ahead and derive it again. And I'll just say make it equal to 0. So I'm just going to put the derivative of it on this side. So when we derive, that's -6 times 2, which gives you -12x. And then 2 minus 1, which is 1. You don't have to rewrite that. And that is -6. Okay, and the x falls away, and so does the 12. It's equal to 0. Then we can go ahead, and I should have just left it like this, but it doesn't matter, it's fine. So now that we have this, I can just go ahead and say, well, take the 12 over. So we have -6 is equal to positive 12x. Divide both sides by the 12 to leave x on its own. And x will therefore be equal to, what is -6 over 12? That gives you -1/2. Okay, so now that we have -1/2, that is the x value of the point of inflection. We have to find the y value, the y coordinate. So to do that, we're going to have to substitute this into the original function. Okay, so we're going to go ahead and say f of, and we'll say -1/2 is equal to. And this is our function, and we're just substituting. So -2, and then in place of x, you're going to say -1/2 cubed minus 3, and then -1/2 squared plus 12, and then -1/2, and then plus 20. And then you can just use a calculator to find exactly what the y value is. And that's really all we're doing here. And the answer we get is 13.5, which you can also leave as a fraction. It's fine. As a decimal is also okay. So there we go. That is our answer for that question. And we move on to the next question. Okay, so 9.2 says the tangent P, which is 3 and negative 10 to a curve. Okay, I like to draw these things down as they say, just so that we know exactly what it looks like. So there's a tangent, right, at P, this point P. So let's go ahead and plot that down. It's 3 and negative 10. So 3 to the right and 10 units down. So maybe let's just say, for argument's sake, it's somewhere here, right? And that is P. So that's 3 and negative 10. So to the curve is given by y equals negative x squared minus 1. Wait. The tangent at P. That doesn't make sense because the tangent, if it's a tangent, it's a straight line. So the tangent to the curve is given by this. Okay. That is supposed to be a straight line equation, but it is a parabolas equation. So it's kind of like maybe the parabola is this. Not sure. Okay, so let me just go ahead and look at this question quickly. Okay, so if you check the marking guidelines of this, they actually do said 9.2, do not mark this question. This question has been removed from the examination paper. So there was probably a confusion with that question. So that doesn't have to be done. And I wanted to do this and just maybe give an equation to this because I thought maybe they actually meant y equals negative x minus 1. But the thing is, they don't really tell us too much about that curve, really. So I don't think it's good to actually do that. We can actually just let it go. It's fine. Okay, so I will skip this question and we can move on to question 10. Okay, question 10 says the profit, which is W of X, earned by a company to manufacture X bicycles per week is given by this equation. So the thing about this is it's given by this formula, but this is the profit that they're going to earn to manufacture a specific amount of bicycles. So depending on the amount of bicycles they will make a specific amount of profit. That's really what's going on here. So X is the amount of bicycles and then W of X is the profit. So the question is, what should the weekly bicycle production be to maximize profit? So what should be the weekly bicycle production? How many bicycles should be produced so that they can maximize profits? So the final answer, they're really just asking you for the value of X, because X tells you how many bicycles was manufactured. So how many bicycles must be created so that the profits can be at a maximum. So this is a calculus question, of course, and we're going to have to derive here. So we're really just finding what exactly is the X value when this is at a maximum. So we can take this that we have, negative X. Okay, it has fractions, so we just have to be careful. So let me actually rewrite this. You see the way this is written? You can actually rewrite this in a way that you can properly derive it. So instead of negative and then x cubed, remember that there is an invisible coefficient of 1 in front of the x cubed. So we can rewrite that as 1 over 150 and then x cubed, then plus 3x squared minus 250x minus 2700. Okay, so this is what we have. And we can go ahead and simplify here. So the first thing we can do is we're going to derive. Okay, remember the idea behind it is you're trying to find the maximum, not necessarily the maximum profit, but the amount of bicycles that must be produced for them to have a maximum profit. So in other words, as a graph, what you're trying to find is you're looking at this. This is a cubic function, and it's a cubic function with its a value being negative. So it's going to be those cubic functions that look like an upside down n. It may not look exactly like that, of course, but just something like that. And what you're trying to find is where it's going to be at a maximum. So you have a local minimum. Okay, that's the lowest part, the lower part, and a local maximum. So these are the points we're looking at, and we're trying to find out where, okay, or which x value at which x value is it going to be at a maximum? That's really what we're trying to find out. What exactly is the x value for the local maximum of your cubic function? Okay, so we can go ahead and derive to find the gradients. Okay, that's what the derivative gives you. So w prime of x is equal to, and we're saying negative 150 times 3. So 3 and 150 have something in common. They have 3 in common. So 150 divided by 3 is 50. 3 divided by 3 is 1. So that is negative 1 over 50. Then we still have our x. And we take the 3 minus 1, which is 2. Then it's positive 3 times 2, which is positive 6. And we have x. 2 minus 1 is 1. I don't have to rewrite that. And then we have minus 250. And we have x to the power of 1 minus 1. And that gives you 0, which of course becomes 1. And so negative 250 times 1 stays negative 250. Okay, so now that we have this, what we can do at this point is we found the gradient, right? Now you need to specifically find the turning points. To find the turning points, you're going to make your gradient equal to 0. Remember, the idea behind this is at the turning points, the gradient is stationary. It doesn't move. It's neither increasing nor decreasing, so it's standing still. That's why we make the gradient equal to 0. And we have 1 over 50x squared and the rest of everything that we have here. So plus 6x. That is a 6, right? Yeah, it is 6x and then minus, why am I saying 2? Yeah, it is 250. I keep getting confused by this. 250. Okay, so this is what we have. And we can, sorry for that. What we can do is now simplify this. Okay, we're going to have to factorize. It doesn't look nice to factorize right now. So what I can actually look at is the fact that we have a denominator of 50. We can call that negative 50 and get rid of that by multiplying both hand sides of this by negative 50 so that that can come out of the way. So negative 50 also on this side. Okay, so we're just multiplying here. That gives you 0 still. Negative 50 times 0 is still 0. Then when we're multiplying here, negative 50 times negative 1 over 50. Now I'm going to give the negative to the denominator because look at what happens. You see, this is on the numerator. You can cancel diagonally. So they cancel out and you're just left with 1. So really you're left with x squared. And then we have 6x multiplied by negative 50. So it's going to become negative first of all. And 6 times 50, 6 times 5 is 30. And then you just put your 0 there. So that is negative 300x. Okay. Then lastly, the negative 50 times 250, negative 250, I mean, that becomes positive. What's 250 times 50? Well, we can say 25 times 5 gives you 125, and then just put your 0 and your other 0. So that's 12,500. Okay, so this is what we have. Then we have to factorize this. But this looks long to factorize, so I'm going to use the quick method. So with the quick method, you just show them, you don't show them that you use the quadratic formula, but you still use it. So this is how we're going to do this. We have 0 is equal to, and we're multiplying, right, these two brackets. What times what gives you x squared? That's x times x. So now we just have to find the numbers, okay? So the numbers that would give us this, but when added, give us this. So we can say negative b, but our b is 300, so negative 300, so minus b, then plus minus, which we just say plus, square root of, and we'll say negative b all squared, so negative 300 squared minus 4 times a, which is 1, times c, which is 12,500, all over 2a, which is just 1. Okay, so you see the first answer you get is 250. That is your solution. It's saying x is equal to 250. So what must the factor be for you to have gotten 250? It should be negative 250. So if you say x minus 250 and you take that over, then you get x equals 250. Or, and then change the sign, and that just gives you just put a minus and you get 50. So x is equal to 50. And then what should the factor have been? Should have been minus 50. So there we go. We have our two values. And I'm glad I drew this graph. Now we can actually see which one is going to be our maximum. Okay, because the question is, we need to find out the amount of bicycles they need to produce for the profit to be at a maximum. So which one belongs to the maximum, the local maximum? Is it the 250 or the 50? It would be the 250. So x is equal to 250 because this one is more on the right. It's bigger than this one. This is the smaller one. That's why that's 50. Okay, so we're not taking that. We're taking this. So let's answer them according to how they asked the question. The question is, what should the weekly production be to maximize the profit? They need to produce 250 bicycles weekly. Okay, so there we go. That is going to be our answer. And that is the final question for calculus. And we will finally, in the last video, move on to probability.